All right, medians and altitudes in triangles. We've already talked about 2 points of intersection that we have, and now we're going to talk about 2 more. What is the median of a triangle? The median of a triangle is a segment that connects the midpoint of a side with the vertex of the opposite side. And when all the medians concur, they concur at a point that is called the centroid. So the median, whoops, I guess I need a pen. The median point of intersection forms the centroid of the triangle. This point is 2/3 the distance from the vertex to the midpoint of the opposite side of the triangle. So it's 2/3 the distance from the vertex to the midpoint of the opposite side. And so what that kind of means is that there is a ratio that exists of 1 to 2 among those sides. So if I tell you that PK is 3, then you know that AP is 6, because the shorter one is half of the larger one. If I tell you that PC is 4, then JP would have to be 2, because the 2 added together make up the whole shape. And that's what this formula is trying to kind of illustrate there. So again, if I tell you that PL is 1.5, then you know that BP is 3 because of that relationship going around the triangle. It's 2/3 the distance. The centroid also happens to be the center of gravity for the triangle. So if you have learned about center of gravity in science, the centroid of a triangle is the center of gravity. So if you find that point, you can balance a triangle on that point. And when I get back to class, I have one that I cut that I can show you. So if we were given triangle PQR, how could we find the coordinates of the centroid? Well, what we would have to do is to draw in 2 of the medians. And 1 has already been drawn in for us. So we would have to kind of think about what's halfway between R and Q. Where is the midpoint located? So 1, 2, 3, 4, 5, 6. So I'd go up 3, 1, 2, 3. So I'd go over 1.5. So the midpoint of RQ is right there, and then drawing in that segment that goes through P that has a different slope than RQ. We don't really know anything about the slopes per se. And then for the midpoint of this one, it's 1.5, and there we go. So I want you to think about how you would find the coordinates of that point when all you know where the midpoint is, you know where the end point is of 2 of the segments, well, all 3 of the segments. How could you find that intersection point? You're going to use algebra and systems of equations to do it, but I don't have time to go through it in this video and not get through the majority of the material. So we're going to move on and let you think about that. Okay, so P is the centroid of triangle MNL. We are told the length of NC, so this whole length right here is 36. So it wants us to find the 2 parts. So what you would do is take 36 divided by 3, and we get 12. And so what that tells us is the shorter part from C to P or P to C would have to be 12. And the larger part from N to P would have to be double that, or 24. And you can double check to make sure by adding those together to ensure they equal 36. And then over here, C is the centroid of triangle GHJ. The length of CM right here is 8 units. It wants us to find the length of HM and CH. Well, CH is pretty simple. We just double the 8, we got 16. And then HM, we would add those two together or multiply 8 times 3, whichever way you want to go. And we can figure out that HM, the whole thing, would be 3 times the length of CM. Okay. So here's another one. P is the centroid of triangle JKL, and the length of PT is 2. I'm going to keep using the red. So find the length of KP. Well, easy enough. We double the 2, we get 4. So KP is 4. Woohoo! Okay, centroid in the coordinate plane. Here are the coordinates. We are told, let's see, find the coordinates of point P. We have D is 2, 3, E is 8, 5, F is 6, 1. The midpoint of DF, this is the midpoint of DF, and this is the midpoint of DE. And so we need to draw in those median segments. I'm going to pause and do that because my ruler's going to slip around. I just know it. Okay, so not only did I draw in the medians, I also found the slopes of the medians because we're going to need that. We got to get the equations of those two lines to see where they intersect. So taking us back to Module 3, where we are going to pick a point on GE. G is as good as any, so y minus 2 equals 3/4 x minus 4, which gives me an equation of y equals 3/4 x minus 1. See if that makes sense looking at the graph. Yes, it does. I bet if I extended this, that would hit down there at -1. And then HF, F looks good. Y minus 1 equals -3 times x minus 6, which gives me y equals -3x. That'd be plus 18, and then plus 1 would give me plus 19, which if we look at the graph, it's definitely going up off the graph. Excuse me. So now we need to see where those two lines intersect by substitution. Since they're both equal to y, we can set them equal to each other. Add 3 to both sides, and over here I'm thinking 3/4 is the same as the decimal 0.75, so I'm going to have 3.75x equals, and then I add 1, I get 20. And then I'm going to divide 20 by 3.75, and I get that x is 5.3 repeating, so I'm going to change it back into a fraction of 5 1/3. And then I'm going to plug it into the second equation and multiply that times -3, and then add 19, and I get the y coordinate is 3, which makes sense with where that lines up over here. So the coordinates of the centroid are 5 1/3, +3. Those are the centroid coordinates, and that's what we were finding. Right there. Okay, now the altitude of a triangle is a segment that's perpendicular to a side, but it goes through the vertex. If you remember, that's different than the perpendicular bisectors. Those did not have to go through the vertex, but altitudes do. That's the difference between them. So the altitude point of intersection forms what is called the orthocenter of the triangle. Now, as far as I know, there's not a whole lot of use for the orthocenter. It's just a point of concurrency. It's not special like circumcenter or incenter or centroid. It's just a point. It doesn't have any special relationships with distance to sides or anything, or vertices or anything like that. So what we have to know is that it's perpendicular to the side and it goes through the vertex. So here is one in the coordinate plane, Hij. We have, this is H, this is I, this is J. I didn't label them. Find the coordinates of the orthocenter. So if it's an altitude, we know that it's perpendicular, which means if we calculate the slope of IJ, 1, 2, 3, 4 up and 2 over, so the slope of IJ is 4 over 2, which is 2, which means the perpendicular slope would be negative 1/2, and it would go through point H. So from point H, I'm going to count that negative 1/2 slope, which would be down 1, down 1. That would be the slope there. Oopsie, I made a mistake. This is a negative 2 slope because I forgot I went left. So the slope would be a positive 1/2. So down 1, left 2, down 1, left 2, down 1, left 2. I'm going to go up 1, right 2, up 1, right 2, so that I can possibly draw the line fairly straight as I go across the graph. And we know that that is perpendicular to IJ. So then we're going to go find another one. Let's see. I think I like the looks of IH, the slope of IH. I'm going to do the same process, but I'm going to pause while I do it. Okay, so I went ahead after I drew the line and I found the equations of the lines through point H and the line through point J, because I need to find out where those two lines intersect. And we see the y-intercept of the line through J. It's right there at 3. So that's negative 3. That's kind of nice to have found that so easily. So now I'm going to solve for the coordinates of the orthocenter by setting those two equations equal to each other. And if you recall, when we did this before, we can get rid of that denominator by multiplying both sides by what would be a common denominator of 10. So I'm going to do that, and it'll magically pop up in the screen because I'm going to pause, and then it'll just right there be there. Okay, so I went ahead and multiplied through by 10. Got 5x plus 15 equals negative 8x minus 30. Solved for x, and it's negative 45 over 13 because the decimal is nasty. So then we're going to pick one to substitute it back in. It's not really going to matter which one I substitute it back into because the number is not going to be pretty either way. So I am just going to go ahead and substitute it into the one on the bottom. And we end up with y equal to negative 3 over 13. Put that in my calculator. Yes, I did. And so the orthocenter is at the coordinates negative 45 over 13, negative 3 over 13. And so the approximation would be negative 5 point something and negative going back trying to find it, and or negative 3 point something, 1 2 3, yeah, negative 3 point like 46 and a bunch of stuff, and then like negative 0.23. So we're like in the ballpark there with our decimals. We got it. So then there is this chart, which is basically kind of a summary of all the different lines and points of concurrency. So you can see how everything relates, and you might want to put some version of all this information on your pink sheet so that you can remember how the things are related, and what the points go with what line, what point of concurrency goes with what line. I will see you soon.